Now let's look at another problem. This problem says a train of mass 55,200 kilograms is traveling along a straight level track at 26.8 meters per second. Suddenly the engineer sees a truck stalled on the tracks 184 meters ahead. If the maximum possible braking acceleration has a magnitude of 1.52 meters per second, can the train be stopped in time? So here, according to my recipe, what should you do first? First, I have read the problem. Now I am going to draw a picture, right? So the picture says that I have a train, right? And it is moving at initial velocity of 26.8 meters per second, okay? And suddenly the engineer of that sees a truck that is on the track 184 meters ahead. So there is a truck that is stalled on ahead, and the distance between this and the truck is 184, right, meters. Okay. Now, he's trying to start to apply the brakes. The maximum braking acceleration has a magnitude, so A has a magnitude of 1.52 meters per second squared. Now, the question is, can this train be stopped in time? So what we are looking for is the final velocity to be zero. Okay? So the question is, can this train be stopped in time? And at the final moment, the final velocity will be zero. So the question basically is asking you, find at final velocity 0 meters per second. How much distance do you need to travel in order for this condition to hold? Okay? Well, let's come up with a good method of doing it. So let's say if I start off by the first equation of motion. What was my first equation of motion? My first equation of motion was Vf equals V naught plus At. That involves time. Time is not given anywhere here. Okay? I mean, I can solve for time, but that's just going to waste time, right? My second equation is delta x equals V naught t plus a half at squared. This equation also has time. We can use both of these equations, but my suggestion for this particular problem is going to be 2a delta x equals Vf squared minus V naught squared. Use equation number 3, because look at what we have. We have the acceleration, we have delta s, or in our case, let's call it delta x, and we have a final velocity that we want it to be 0, and we have an initial velocity. So we pretty much have everything that we need. So that might be a good way to solve this problem. So let's try to solve this problem using this equation. Okay, 2a delta x, this is what we were looking for, equals Vf squared minus V naught squared. Okay? So 2, put the value of 1.52. Now this is being decelerating, so I'm going to put a minus sign here. Meters per second squared. Delta x is what I'm looking for. Via final, I need it to be 0. And my initial velocity is 26.8 squared. Okay? So all I did was I chose correctly the equation I wanted. I plugged my numbers in. I do a little bit of algebra, move things around, solve for it, and my delta x comes out to be equals to 236 meters. So this is going to be my stopping distance for the train, okay? This is the distance that this train will require to come to a complete stop. This is the distance between the train and the truck that stalled. So now, obviously, the train is not going to be able to stop. So the people better get out of the truck really, really fast.